next speaker, Vijayan SR, from ABB, who's going to talk about how we can perhaps see that IoT come into reality. So let's move on to that. Thank you.
So good afternoon, everybody. I'll just take a few minutes, not too long. So basically what we'll be is, trying to see is to take a glimpse of why we are talking about IoT in a power system perspective, and what we mean when we say, we'll have to implement a solution, around this technology. So what we see is, the challenges and challenges, for the utilities are changing. What we were talking about a few years back, 24 bar 7 power supply and then quality of power is now changing, more of towards renewables, the unpredictability, the intermittency, and then, the consumers changing to prosumers. So all this, dynamics coming into the system. And then the cyber security is a very key concern. 3-4 years back, when we talk about automation, people used to ask what should be the communication media, what is the response time. But today when we talk automation, people ask what is the mitigation techniques, cyber security mitigation techniques that you are trying to embed into a solution. So the concerns are changing. And then though we talk about energy surplus and adequate power supply today, but we as a human, we are intelligent to know how to consume what we produce. So so there is going to be increase in the demand. So that has to be met either through renewables or the other generation techniques. And then the infrastructure, so what we build on the network, the transmission distribution network, and including the power plants, the assets are becoming old. They are 40-50 years old. So how do we manage this? So these are the challenges. So from the delivery point of view, it's becoming more of protecting and managing the network assets. And this is from the industry point of view. So there is the comparison between the revenue generated and the OPEX spent. And then cyber is again a concern for any control system automation. So cyber security is a concern, and aging workforce and the assets as such. So to meet these challenges, we have talked a lot of the microgrid technologies, the stabilization of the methods in the transmission network, the market systems, and what we also see is the asset management system, which is one of the key area that is being looked upon both from the transmission and the distribution companies, how to manage and do the predictive and prescriptive maintenance rather than doing a periodic maintenance. And more from the manufacturing point of view, people are talking about robotics, automation of robotics, and having sensors with the building management system, building automation systems. And then we also talk about the remote monitoring and optimization of the entire assets. So though we saw the various solutions being deployed, we will see some of the key solutions that people are talking about, like asset I already mentioned, the asset management and condition-based monitoring. So what it means that the primary equipment which are there in the substations, so they are not only going to perform the the electrical the performance that they are meant to do, but they are also going to have intelligence, add sensors into them so that they can send data to the control system where the data can be analyzed. We talk about analytics and the of course little bit of AI and machine learning being included into the analytics part. So these equipments which are dispersed at the substations, and we also talk about going beyond the substations when we talk about their distribution transformer monitoring. We talk about LT automation systems. So these devices which are spread across the the area and the geographies, so they are going to become more intelligent, and they are going to be communicable. And so next what we see is the solar. So we have talked about a lot of solar, the distributed generator, and we also talked about the solar parks. So to have the smartness and to have the remote monitoring and focusing is one of the key requirement, because though we talk about the unpredictability nature of the generation or the availability of the resource, the focusing is a key area where the accuracy of the focusing needs to be is to be met, so that the scheduling generation scheduling can happen as planned. So these things require where these the solar panels or the remote generators or in the remote places are connected in a way so that they can talk to the central system where they can do the analysis and then have these forecasting applications and scheduling applications run. And we also talk about the asset management of these these generators, distributed generators, where if there is the failure of asset that is going to happen, the behavior pattern of the assets can be monitored, and the systems can be addressed, the breakdowns can be addressed before they actually break down. Okay, so these things are what we are seeing, and of course we had a separate session on electric vehicle charging. So again, these are all not going to be isolated machines which are just going to charge the cars or any vehicles for that matter. So how do we manage the grid? We talk about grid management, when electric vehicles are going to be there. We talk about all electric by 2030, and yesterday we heard Mr. Mahesh from Mahindra talking about, if not private vehicles, at least the fleet vehicles will become electric, like the Olas, Ubers, and then the public transport systems. So if there are going to be so many vehicles around us on electric, so the number of charging stations are going to be increased. So how do we manage? So it's going to be, it is going to form its own grid, like EV grid. There's going to be EV grid. So how do we integrate those grid with our traditional electric grid? So these independent charging stations or the charging mechanism needs to again get integrated into the system. So you can see on the on your right side what we are talking about, right? The charging stations are getting signals to the central system where we can do the remote monitoring, and even the remote services is one of the key topics. So it's not, when you have the dispersed assets spread across your location, so you cannot be sending people everywhere. So you need to have some kind of remote service possibilities enabled into the system. So when we talk about these kind of applications, so this all these technologies are enabling factors today to have more and more analytics possible, the data, the big data analytics and the artificial intelligence. When we talk about the machine learning, and how do we derive our prescriptions from the data that is being collected from the field. So data is not no more a data, like when we talk about the conventional SCADA systems, it was more or less for alarming and trending, but today we talk about much more of prescriptive information coming out of this data. So this is what we talk. So basically, when you take a SCADA system, or when you talk about automation systems, we the substations which are more or less in a big reachable locations. So they get connected to the control center, which is very easy. So they are very few in numbers. But when you talk about the primary equipment getting intelligent, and sensors getting installed into these devices and spread across the geographies, how do we make them communicable? We cannot have a point-to-point connection from each device. So that is where this concept of IoT, or Internet of Things, and cloud computing comes into picture. This slide shows the different architectures. So you can see the different sensors itself acting as an IoT device, or you can have a club of sensors which can then have an IoT gateway. And here we are seeing a vertical architecture. On the right side, we are seeing a vertical architecture where the sensors come into zonal, and zonal gateway, and zonal gateway gets connected to the central gateway. So there are different architectures, and there are different ways of implementing these IoT and cloud systems. You can either have your own cloud, or you can share the cloud, because there are a lot of technologies and a lot of cloud frameworks, platforms available. And so these resources can be shared. When we want to implement an IoT kind of solution, we don't have to go for an independent cloud every time. Okay. So final slide. So these are the key takeaways. So digital transformation is happening and is here to stay. We all know that. We are all very willingly embracing it for improvement of the systems. And it's important to know the applications. Why we are implementing an application? Why we want the data from the field? What is the purpose? And what we are going to derive? And what is going to be our the actions based on the data? So that needs to be very clearly understood before just going for data collection from all the devices. And then choose the right architecture. So it is important that we should understand what is how the architecture need not be standardized. Okay, it should be on a case to case basis depending on the specific requirement of the geographical reach, the devices, the sensors, and again it is linked to the applications, what kind of applications we want to link. And all this should be in a strategic approach. It should not be like, yeah, I'm looking at, today's requirement and then doing something, and then after 5 years, I have to redo the same thing. So it should have a more strategic approach. So that's it from my side. Thanks.
Vijayan, can you stay on for 1 second? Thank you. From ABB's perspective, when you think about IoT, what are your big challenges of taking something out of the lab and deploying it in the real world? How do you sort of think about that?
Yeah, so as I was mentioning, the first, the understanding is why we want to implement. So what kind of applications we are looking at. For example, if we take the asset management, okay, so whether we want to do condition-based monitoring on a real time, or we want to do prescriptive kind of information coming out from the system. And once we decide that, so what are the equipments we want to automate? So whether we want to automate, I mean, it's easy to understand from the, the power system point of view, the transformers or the circuit breaker, and how do we, make these elements intelligent by adding sensors, what type of sensors you want to add. So that should be a kind of a proof of concept. And the proof of concept is to know the technology. The cost can be a factor, but it should not be the factor. But it should be more of understanding the technologies, and then the scalability part should be included as part of the POC.
Okay, well, thank you for your work. ABB is obviously leading the charge in so many of these areas, so thank you.
Thank you. Thanks so much.
Appreciate it.